Good morning, students. Welcome to online classes on continuation of electrical and electronics measuring instruments. Today we are going to cover electro-dynamometer type instrument which is used in our laboratories as a wattmeter, ammeters and voltmeters. And this topic is regarding to third semester EEE students EE 304 C18 scheme. In last class we have covered moving coil instruments, its construction, working principles, as well as moving iron instruments, its constructions, working principle of attraction type and repulsion type instruments. At the same time, we have compared few important aspects among moving coil instruments and moving iron instruments and other type of the instruments also. In this class, we will explore some more important things regarding to our electrical instruments. Today objectives: on completion of this period, you would be able to know the construction of dynamometer type instrument, the working principle of dynamometer type instrument. Dynamometer type instrument act as a voltmeter and ammeter separately. Then what are its connections? And finally, we are going to cover what are the merits and demerits of dynamometer type instruments. Let us see one by one and clearly but slowly. Now you can see, so this is already you have seen, this is a moving coil instrument, well known, where it has the U-shaped permanent magnet which is made of all nickel material, all nickel material, aluminum, nickel, cobalt alloy with some iron, and it is a permanent magnet. It produces a stationary flux. In North Pole and South Pole there is a magnetic lines of forces. In between two poles there is a electromagnetic is producing due to the coil arranged in this one. It is placed on a spindle. For the free rotation we are provided the jeweled bearings at both sides, and spindle is attached to the spring and attached to the pointer, at the same time spring also for controlling purpose. Okay, everything already you know this thing. Our today topic hero is dynamometer type instrument. That is a similar in construction and operation of moving coil instruments. How? Let us see what is the difference between two. Now here the moving coil instrument, what you have seen, the North Pole and South Pole, and in between there is a aluminum frame on which there is a conductor coil, and the coil two ends are connected, upper spring and lower spring, which is made up of the phosphorus branch spring. When the variable which is to be calculated found is connected to the positive terminal of this meter, that variable whether current or voltage enters into our coil through spring and circulates. Whenever the current passing through the current this winding, it establishes its own magnetic field. Already there is a permanent magnetic field and both interaction takes place. There is a torque is developed. Due to the torque, the stationary magnetic fields are stationary position, and whereas our rotor, nothing but our coil, is placed on a jeweled bearings which can rotate easily. Due to the interaction between the stator magnetic field and coil magnetic field, there is a torque is developed. Due to the torque, the coil will rotate. For example, in this case, if it is rotating in the clockwise direction, then spindle also rotate. Once spindle rotates vertically, then it is connected, attached to the one pointer which is moved on a calibrated scale. Now, this is our electrical circuit diagram, and this is our real time moving coil instrument. Just what you have seen, please recall it. In our dynamometer type instruments, instead of using this permanent magnet, this is also we are using the electromagnet. Same principle. Here northern pole is a permanent magnet, all nickel material. Instead of that one, I connected the one coil here, one iron piece, and connected the iron piece and here taken. So what will happen? Whenever the current passing through this one, it establishes own magnetic field. We can say this is a fixed magnetic field. So here, instead of 100 turns, 50 turns are placed here, 50 turns placed here. Then thereby it acts as a fixed coil. And automatically this is a coil which is in between the two electromagnetic field and the another coil. So same operation of moving coil instrument of our today topic instrument. Dear students, don't confuse. In moving coil instruments, we use the one is the electromagnet, another is the permanent magnet. Whereas dynamometer type wattmeter, we are using the both are the electromagnets only. Similar operation. Okay, so let us see in clearly. What is this one? You can see this is a permanent magnet, and you can see the our dynamometer type instrument. What you are observed here? Here, this is the U-shaped magnet. In place of U-shaped magnet, I placed this magnet, this coil, and this coil act as a U-shaped magnet. And this coil which is placed in between the two poles, I placed the same coil here also. Same spring, same spring. Same spindle, same spindle. Everything is okay. Okay. Now, what is the main difference? You can see the physical point of view. Here I use the two electromagnets, and in this case I use the one permanent magnet, another is electromagnet. Here is this is the one electromagnet, this is the another electromagnet. The working principle is similar. Okay. Now you can see our electrical circuit diagram. You can easily understand what is the connection. So you can see then here, what is this one? It is a moving coil instrument diagram. North pole and south pole, in between there is a lines of forces. In between we have placed the one sensitive coil, and coil is placed on a spindle, and spindle is placed on a jeweled bearings, and it is provided with a pointer and a spring control method and different methods. Now you can see this is a electrodynamometer type wattmeter connection. Here is a fixed coil 1, fixed coil 2, and in between there is a moving coil the coil which is placed middle, and it is connected in series one resistance, you can observe here. So, this for example north pole, this is the south pole, here the north pole and south pole, and this coil is nothing but this coil, and the coil is placed on the spindle, and here the spindle and elements. In extra, here the coil is attached to the some resistance, series resistance connected here, because we are connected across the supply. To limit the current, we are connected one series resistance in series with the moving coil. So, the moving coil can be used as a pressure coil, whereas the fixed coil we can say as a current coil. Okay. So, the basic idea of this one. So, what is the instrument here? What is the main basic principle? Dear students, you can see it. The main principle is that the mechanical force exists between two current carrying conductors. Previous case, you can see the figure. Here, what is happened? The main principle is that the mechanical force exists between two current carrying conductors. Here, this is a current carrying conductor, and this is a current carrying conductor, and this is the current carrying conductors. In between, I placed the another current carrying conductors, the north pole and south pole. This is a coil, it is also produces a flux, and interaction this one, it will operate. What is consists? They consist of mainly the construction point of view, it consists of a fixed coil. We can say this is a fixed F1 and F2. The fixed coil and this is a moving coil. The fixed coil split into the two halves and kept closely and parallel to each other, and moving coil which is placed in between the two fixed coils and pivoted between two fixed coils and mounted on the spindle. A pointer is also attached to the spindle as usual the previous one. Okay. Now, you can see it. The fixed coil wherein are more connected in series. So, here you can see this is a fixed coil, this is a fixed coil, this is a fixed coil. The fixed coils are connected in series with the load. So, you can see this is a coil, this is a coil, this is a load, and is connected here. There is a 100 tons, 50 tons here and 50 tons here, connected in series with load. So, it is called as a current coil. We can say the current coil. Current coil means whatever the load current that can bear it. That is why we can see in previous figure what is the physical construction. So, you can see here this is a current coil, this is the voltage coil. The thickness of the wire you can observe it. So, fixed coil having the less number of turns, but thickness is more and more, whereas the pressure coil or voltage coil, so very thin diameter and having the more number of turns, whereas this fixed coil having a, so that is the fixed coil having a large, the diameter is more, but thickness is the thickness of the conductor is more and the number of turns are less, and these turns also hollowed make the two parts, one part is here, another part is here, connected in series. Whereas, so it's whatever the load current, it is a load current which is the current is flowing here. So, whatever the current is, it is connected. This is a coil, nothing but this one, and this coil, this one is connected to the load. That means whatever the load current, that current has to pass through these two coils. Hence, the thickness of the fixed coils are more. Okay. Now, the moving coil, which is EM in between, is connected across the load or across the supply. Now what is connected? Here you connected this coil across the supply, phase and neutral, through some resistance is connected here. Whereas, so it is known as a voltage coil or pressure coil, and carries the current proportional to the voltage of the circuit. It is said is a pressure coil. A high resistance R is connected in series with the pressure coil to limit the current through it, because it is connected across the supply. Okay, the electrical circuit point of view, you know everything. Now, this is a comparison between the already known thing, moving coil instruments, and unknown thing, the wattmeter. The operation and construction somewhat you are cleared. Now, let us involve our concentration on only wattmeter. What it contains, you can see this is a wattmeter generally used in our laboratory. The wattmeter is an instrument for measuring the electric power in watts of any given circuit. In previous class, you have seen that, for example, there is one bulb is connected here. The bulb is connected from the source. For example, you take the source. Now it is connected through the switch and is connected here, it is connected here. I want to know the current. What is the current taken by this bulb? So I can connect the one ammeter here. So I can easily know by connecting the ammeter in series with our circuit. Now I want to know what is the voltage across the bulb. Then I connect the one voltmeter. So I connected across this one. It will measure what is the voltage across these 2 points, or similar to what is the voltage between positive and negative terminals. Now I want the power. Suppose in case of DC, we know that power is equal to V into I. You know the voltmeter reading, we know the current voltmeter reading, so we can easily calculate the power we get. For example, if I am taking here AC, then what will happen? So power is equal, you know that V into I into cos phi. What is the cos phi? PF, power factor. From voltage can be obtained from the voltmeter, and current can be measured from the ammeter. Then power factor, what is the power factor? Then the DISCOM people will give the power 0.85 for the domestic, lagging for the domestic purpose. So here we connected the resistive lamp resistance. The power factor is equal to UPF, let us assume. Then cos phi is equal to 1. Then what is the power? Power is equal to voltmeter reading, ammeter reading, if the load is the purely resistive. Okay. Now I want the load connected to the one fan, ceiling fan. So nature is the inductive. Then here what will happen? The current which is flowing through the ammeter and voltmeter is connected across the fan. It is connected to the, for example, AC supply 230 volts. Okay. Now what will happen? Now in this case, power is equal, P is equal to V into I into cos phi. Now cos phi may not be one value in this case, because inductive nature, it should be lagging power factor. Then I want to know power in the circuit with the help of one voltmeter, one ammeter, and another power factor meter. I am going to connect the one meter. So to find the power, I require the ammeter, I require the voltmeter, I require the power factor meter. 3 meters is required. That is the problem. So instead of using 3 meters, I can use only 1 meter. That meter is known as the wattmeter. Whether you are going to calculate the power in DC or AC, it will directly measure the power in watts at a single meter. That meter is known as the wattmeter. The wattmeter is an instrument for measuring the electric power in watts of any given circuit. That may be resistive circuit, that may be inductive circuit, there may be capacitive circuit. What is inside? So, we have seen previously the figure, it has a fixed coils and moving coil arrangement. You want to know in details about inside the parts. So, the electromagnetic wattmeter are used for measurement of utility frequency and audio frequency powers. Okay, that means another one thing, the electromagnetic wattmeter. Wattmeters have different purposes. The electromagnetic wattmeters are used for measurement of utility frequency and audio frequency power. So, audio frequency means, so just like is a FM radio in megahertz, and also other types are used for radio frequency measurements also. Okay, these are the some applications of wattmeter. So, what is the symbol generally observed while drawing in first year level? So, wattmeter is shown with the help of simply ammeter by A, voltmeter with V and wattmeter W. Okay. So, you can see it. So, this is the wattmeter symbols and connections. It consists of current coil connected in series with the load and voltage coil or pressure coil which is connected across a load or supply. So, voltage coil measures the voltage and current coil will measure the current, and voltage and current and phase angle between this indicated on a calibrated scale when it is connected in the circuit. Okay. So, let us see what are the different types of wattmeters generally used in our electrical fields. Types of wattmeters. So, as you observe, this is a wattmeter generally used in our laboratory. The wattmeters are generally the dynamometer type wattmeter and induction type wattmeter and electrostatic type wattmeters. These are the three very famous wattmeters are generally used in the laboratory. In laboratory also LPF wattmeter and low power factor UPF power factor. Low power factor wattmeter and UPF unity power factor wattmeter generally used in case of our experiments in our laboratory. Okay. And coming to our circuit diagram, electrical circuit diagram in our wattmeter. You can see it simply previously the supply, whatever the supply is given, that these two terminals, the fixed coil, coil 1 and coil 2 connected in series. This is the F1 and this is the F2, total turns split to the off, connected in two places and connected through load, and this circuit is closed. Whatever the current comes here through the load, it will measure what is the current. Now, at the same time, this current also flowing through the moving coil which is connected in between the two fixed coils, and extra resistance also connected, series resistance connected for the protection purpose. That means this is nothing but it is connected across these two terminals. It is known as the voltage coil and it is connected in series. It is measured the current. So, the current coil. The current coil and the pressure coil both are connected here. You can see it. Now, the pointer is placed on the moving coil and which is moved on a calibrated scale. So, this is inside the wattmeter. Only outside we are going to see the outside is the calibrated scale and pointer only. You can see that is also. This is a practical wattmeter generally used in our electrical fields. So, what is inside? This is a circuit inside. only. So in plan we are going to just needle, it indicates the what is the range of watts consumed by the load. This wattmeter measure up to 1000 watts, 1 kilowatt. Based on the input current and voltage, proportionally develops a TD, that is a deflecting torque. The deflecting torque moves the pointer to a corresponding value where TD is equal to TC, controlling torque equal to deflecting torque. Okay. Now, what are the salient points of this wattmeter? Now, you can see it. It has mainly 3 coils, as you know that. What are the coils? 2 fixed series with the electric load. So, here 1 and 2 connected in series with the load. Color change, you can green color, you can blue color. Okay. Here what is happening? The 2 fixed series, this one and this one, 2 fixed series with electrical load. The series coils measure the current flowing through the circuit, load current. The moving coil is in parallel with it. Here the moving coil is this one, parallel to this coil. The parallel coil measures the voltage, it is nothing but measure the voltage. It is situated between the 2 fixed coils and is attached to an indicator needle. You can see this indicating needle. Okay. So, these are some salient points. 2 fixed in series with the electrical load, and the series coil measures current flowing through the circuit, and a moving coil in parallel with it, and the parallel coil measures the what will measure? It will measure the voltage. Simply you can see it is connected across this terminal voltage, and this coil is measure the in series to the load, measure the current. Now you can see the what are the, if you are observing practically how this is manufactured, you can see the physical figures. Now you can already you have seen this one, what it contains. Here is the fixed coil 1, fixed coil 2, and connected in series, and here is the moving coil is connected here, and it is connected to the spindle, and is connected on spring here. You can observe here is another spring, and a point is placed here, and calibrated scale is here, similar to the previous one. If you want to see in a front elevation how it will see, you can see another figure similar. If you are seeing this direction, you are going to see it. So this is a F1 and F2 connected in series, you can see here, and this you are going to spring, and you are going to see the pointer which is placed on the calibrated scale. Okay. So pointer you can see, scale you can see, voltage coil you can see it, and where is a control spring, you can see it for the controlling torque, and current coil also you can see. What is the purpose of current coil? Current coil is a fixed coil. It will carries the current, load current. Where is the voltage coil? It measures the voltage. It is placed in between the 2 fixed coils. You can see it. Now let us see this one. What are the main parts in a instrument? Parts of a dynamometer type instruments, let us see. It has a fixed coils, moving coils, control springs, damping equipment, and shielding equipment. Shield, it is required the shielding, and scale and case. So what are these parts? As you know that fixed coils F1 and F2 fixed coils for the production of 1 plugs. Moving coil is this moving coil placed on some rectangular frame to produce the another flux. Controlling spring, here we are going to use the spring control. And the damping equipment, so here there is a damping can be produced, eddy current damping, fluid friction damping and air friction damping. What are the damping you require, you can use it. Now shielding equipment, because there is an extra, this is a magnetic field, this may be affected by the keeping the magnets and outside. Stray fields may be affected on the ground. That's why it is placed in the shielding by steel coating on a steel material. Steel coating on some metal, it can avoid the entering of the outside electromagnetic field on the inside magnetic field. And scale, the scale, case, total case you are going to, the wooden case, bonnet case generally use this. Okay. Now next coming to the each part. So what is the each part here? Now see that they produce the magnetic field required for the instrument. Fixed coil. What is the purpose of fixed coil? The salient features of fixed coil. Here you can see it. What is the purpose of fixed coil? Already we know this one. What is the purpose? It produces the magnetic field required for the instrument deflecting torque purpose. And at the same time the fixed coil is divided into two sections, F1 and F2. To produce more uniform magnetic field at the center allows the passage of the instrument shaft. So here in between there is a strong magnetic field, here and center we are going to pass the one spindle. Shaft is placed in the bearings. They are wound with a fine wire for using as a voltmeter, while for the ammeters and wattmeters it is wound with a heavy wire, because for ammeters and wattmeters you draw directly the load current. That's why it is a thickness of the fixed coils are very high in case of the wattmeter and ammeters, whereas in voltmeter the wire may be a light thickness, gauge is very high, thickness is less. They are varnished and baked to form a solid assembly, because on the varnished coated on the copper coil wound and varnished coated and baked, that is heated, so to dry perfectly. Thus a solid assembly makes a construction rigid, it will not move in the other direction while you are using operations. They are mounted on a ceramic support to reduce the eddy current losses. If you are using any metal parts, there is a possible to produce the unnecessary eddy currents. To avoid that one, we are using here our two coils are fixed on a ceramic body rigidly. Okay, these are about the fixed coils. Okay, what is the fixed coil? They produce the fixed coils. They produce the magnetic field required for the instrument, and fixed coil is divided into two sections and to produce the more uniform magnetic field at center, because if you are placing the only one, so only one, there is no uniform magnetic field. That's why they are placed at the cutted and placed at the two portions in between the moving coil is placed. That's why the uniform magnetic field spread around these coils. To allow the passage of an instrument a shaft also, and they are wound with a fine wire for using the voltmeters, and while for the ammeters and wattmeters it is wound with a heavy wire and a heavy gauge. They are varnished and baked to form the solid, and solid assembly make the construction very rigid. They are mounted on a ceramic support. What is the purpose? If you are using the metallic part, so metals as a conductor, due to the magnetic field, eddy currents develops, due to the eddy current heating takes place. Okay, to avoid that one, it is placed on a ceramic body. Have you find the ceramic? Just like the insulators generally you are observed in a nearby your outside poles, PSC poles, current poles. There is a R phase, Y phase, B phase and a neutral. R phase having the one ceramic, the insulator, Y phase insulator, B phase insulators, and ground there is no insulator. Shackle insulators you can observe in case of the wells. Okay. Now coming to the another coil, we have seen the fixed coil. What is this? Salient bands. Now let us see the moving coil also. The moving coil, what is the moving coil? So in place, in between, this is the moving coil, in between this is the moving coil. Now we are going to study this about this one. It is an air cored coil, not placed any type of the core material. Wound on a non-metallic former to reduce the eddy currents, as we already said that no need of the end metallic parts. It is located in between two fixed coils. At the what it contains? It contains the spindle is attached to the coil. Spindle is supported in a jeweled bearings at top and bottom. What is the jeweled bearings? Jeweled bearings is nothing but frictionless bearings. Okay. So now a moving coil mounted on a aluminum spindle. So aluminum spindle which is ready to move, and counterweights are also provided on this one as a purpose, the balance purpose, and a pointer and a control springs are provided on this one. Okay. So these are the different parts on a moving system. Now spindle is this thing. Or what are the other moving systems? Here the moving coil mounted on a aluminum spindle, it is the most spindle also moving, and counterweights which is connected to the pointer, that is also moving, and a pointer also moving on a calibrated scale, and control springs which is placed on the spindle at both sides, they are also moving. This is a moving mechanism in our dynamometer wattmeter. Now what are the different of the control systems? Control torque and deflecting torque, how we are going to produce. Now we have seen that the fixed coils and moving coils produces the deflecting torque. Now to oppose the deflecting torque, we require the two other opposite torques, that is the controlling torque, another is the damping torque. How we are going to produce this type of the torques in our dynamometer type instrument? The control torque is produced by two control springs. Previously we have seen in the figure. The two springs, phosphorus branch hair springs, are placed at the both sides. One is the one direction, another is the another direction. This creates the controlling torque. Springs also act as a leads to the moving system, which will carry the current from outside. One is act as a two terminals. Whereas the damping is provided by the fluid friction damping. Vanes are provided generally. Two aluminum vanes are attached to the spindle at the bottom. So these vanes are moving in a sector shaped chamber which has some liquid. So liquid opposes the movement of the easy movement of the vanes. That creates some resistance opposition to the deflected torque, which can avoid the oscillations of pointer at final position. Okay. Now coming to the another part, shielding. What do you mean the shielding? The field produced by the fixed coil is very weak. So that is only that easily confused, that can be interfered by outside stray fields. So it is nearly, what is the field? Nearly very less, that is called 0.005 to 0.006 Webers per meter square, that is the Tesla. So 0.005 to 0.006, that is a very less the magnetic field produced by the fixed coil, that can be influenced by the magnetic field if you are placing nearby that one. So that's why whatever the outside magnetic field does not interfere our fixed coil produced magnetic field. That's why we require the shielding is necessary. So what have you seen? So you can see the black color, the wattmeter, the shielded material. The shielding is necessary to protect the instrument from stray magnetic field from outside. Shielding is provided by the high permeability alloy casing. You can see it. The shielding is provided by high permeability, high mu. So alloy casing. You can say, sometimes we can see the wooden case also used for this purpose. Okay. Now shielding already we have seen. Now what is the remaining part? So scales. So you know the scale. What do you mean the scale? The scales are hand drawn using machine, dividing the equipment. Most of high precision instruments have a 300 mm scale with 100, 120 or 150 divisions. You can see this one. Okay, these are the different type of the scales used in different instruments. You can see here. These are the two wattmeters. Scale division is based on our applications. Now, so these are the different parts consists in a physical wattmeters. What are the parts we have seen and what is the purpose of each part already we covered. Okay, so what is the spring, what is the damping torque, and what is the fixed coil, what is the moving coil, what is the spindle, everything we have covered. Now let us see the principle of working of operation of a dynamometer type wattmeters. The working principle. What is the working principle? You can see it. The interaction of the flux produced by the fixed coils. Where is the fixed coils? So you can see this is the one fixed coil, this is the fixed coil. The interaction of the flux produced by the fixed coils and moving coil. Where is the moving coil? This is the moving coil. So these fixed coils produce some flux here and moving coil produced by the flux here, and due to the both fluxes there is a torque is developed. Due to the torque, the spindle will move on which our coil is provided. Thereby pointer also move on this one. Okay, you can see this our diagram representation. Now here our current coil is the two fixed coils. We are connected here the current coil connected in series the load. Whereas the pressure coil, this is the pressure coil, is connected across this one through high resistance material. Okay. Now the instrument is connected across the load to the measure the power, where we are going to require to know the load. So we are going to connect these instruments. You can see here what is the figure is given. So same thing. Suppose similarly I am going to connect here. Here is one bulb, here is one bulb, here is one bulb. I want to connect here. So I want to know that. So how we are going to, this is the CC coil. I am going to connect to the pressure coil. It has some resistance connected to this one. Now I am connected here, the phase and neutral here. What will happen? So I want to know the power of this one. Suppose one switch is closed. Then what happened? The current which is passing through this one is flowing through the CC coil and flowing through the PC. Okay. Now what is the one bulb is glowing? Then it will draw the current through. The current is passing through the, you can say take another color. Now you can see. So here the current is coming. Some current is flowing through this CC coil and is connected to the ear, entered here, we going, and this circuit is closed. At the same time, some of the current also passing through this coil and here. That means this current is measured by this coil is measured produce the flux, the fixed flux, and measure the current proportion to the load, and this is the pressure independent of the load. It is connected across the two terminals. It measures the voltage, it measures the current, and it will give a reading. You can see the reading based on the deflection torque produced between these two interaction of the fluxes. Now if you connected another load, what will happen? the further current increases, voltage may be remain constant. Then what will happen? The fixed coil which are produce a more flux. This flux, due to the more flux, there is a deflecting torque is more and will move the pointer from this position to the another position. If connected another bulb, then what will happen? The current further increased. The flux produced by this fixed coil further increased. The deflection on it moves the moving coil further, thereby it will rotate further and the pointer will rotate further. That means, so initially one bulb, this is the reading, second bulb, this is the reading, third reading, this is one. That means when our current is increases, the flux produced increases, the deflecting torque produced increases, thereby the pointer which is moving on a calibrated scale also changes. Okay, so directly, so the wattmeter will shows the what is the power consumed by, for example, 100 watts, 200 watts, 300 watts. 3 bulbs are connected, each 100 watts. Now, once first bulb is connected, it will show the 100 reading. Second bulb is connected, it is a 200 reading. A third bulb is connected, the 300 readings it will shows. Okay. Now, so the instrument is connected across the load to measure the power. The current is divided into two parts. One part I1, you can see here one current, this is the I1, this is the I2. So I1 flows through the current coil, fixed coils, and the second part I2 flows through the pressure coil, the moving coil. Both fixed and moving coils produce the fluxes in between the fixed coils. The interaction of these two fluxes produce a force on moving coil. You can see here another figure. So this act as a one coil magnet, this act as another magnet, this is a one F1, F2. So in between there is a magnetic fields, and the same time when supply is given, the coil has produced magnetic field, that proportional magnetic field, so there is a torque developed in between two. Okay, the interaction of these two fluxes produced force on the moving coil, because moving coil is based on a bearings. As a result, the moving coil rotates as it is free to rotate because provided on a jeweled bearings. The pointer shows the corresponding power value on a graduated scale placed here. So based on the deflecting torque it will move, so which based on the intensity. The deflection torque or force on moving system depends on the current strength. The current in the pressure coil is proportional to the voltage impressed across the coil. So here, because the moving coil is connected in parallel and fixed coil is connected in series. The fixed coil is the current proportional, and whereas the voltage is the fixed one, is connected across the supply. Now, what is happened? Thus the deflection is decided by, so deflection torque is TD is directly proportional. What is the factor? The product of RMS value of two currents. Here, what is the two currents? I1 in the fixed current and I2 is the moving coil. The two currents and cosine angle, phase angle between the two, and the rate of change of mutual inductance. These are the product. That means the deflecting torque is decided by product of RMS values of I1 and I2 and cosine cos phi between the I1 and I2, and also the rate of change of mutual inductance, the change of mutual inductance. So the dynamometer type instrument can be used for AC as well as DC purpose. We can use both AC as well as DC purpose, whereas a moving coil instrument can be used for only for DC purpose. Okay, but whereas in this case this can be used as a AC as well as a DC to measure the power in the circuit. Okay, you can see this figure also. Now you can see this is a wattmeter. Generally wattmeters or dynamometer type wattmeters. Now working of dynamometer type wattmeters. So these same dynamometer type meters can be used as ammeters, it can be used as a voltmeter, it can be used as a wattmeters. In first case, now we are going to use this instrument as a wattmeters. So if you are connected wattmeter, what is the changes takes place? Here you can see this is the general meters. So we have seen previously, so if this is a wattmeter, we connected, so it connected in wattmeter, and same is connected in the ammeter. So in this case ammeter, so here what will happen? The fixed coil and moving coil, two parts. At the same time, the moving coil also connected. Here what will happen? This is the fixed coil and this is a fixed coil and is connected the load and here. And we taken this one coil and is connected here previously. Now what is happening? This is a parallel, this is a series with a load. Now in this case we are taking that such a way that what is taking the fixed coil and this is a fixed coil and this is a moving coil. So all are connected in series only. Now it is connected to the load. You can see whatever the current is coming through this one, same current is flowing this one, same current is flowing this one and same current is flowing in this one. But you may ask one question, sir, what is this value is placed in the very thin conductors. How can bear the load current? That's why I connected the one extra resistance to divert whatever the extra current is coming to this coil. Just like it is a shunt in case of the extension of ammeters. So this arrangement can be used as a ammeter. This is the dynamometer type meter can be used as an ammeter to measure the current because all coils carrying the current same. So whatever this flux and this flux, same flux interaction takes place, but it is a moving coil is placed on a spindle, it can easily rotates. Okay, now this is the thing. Now if you same this is the ammeter, you can see this is the ammeter generally used in laboratory. This is the dynamometer type ammeter. So moving coil ammeter, moving iron ammeter, dynamometer type ammeter can be used in our laboratory, but it gives the accurate. Now if this ammeters same wattmeter it can be used as a voltmeter. Then what is the connections you can see here. So here it is connected similar to that one previous case. Okay, scale is uniform, this is connection, everything is this one. Okay, so same voltage proportional to the voltage. So you can see this is a one diagram. Two coils, all coils are connected in series and whatever the flux produced that is proportional to the voltage potential difference between the 2 points. So that is known as the voltage. Okay, so in this class we have discussed what are the points we discussed. So here discussed what is its construction of wattmeter and how this wattmeter can be used as a wattmeter, ammeter and voltmeters. At the same time, what are the advantage of this dynamometer type meters? Because we know that here it is a scale is advantageous. What are the advantages? You can see it. So last just 1 minute. And what are the advantages? What are the disadvantages? Wattmeters. So it is a scale is uniform. Scale is uniform, just like moving coil instruments. It is a high accuracy meter. Accuracy point of it is a very good, and it can be used AC as well as the DC also. And it is free from hysteresis and eddy current losses generally. These are the advantages. And whereas the disadvantages mainly, so at low power factor LPF, low power factor meters, inductance of the pressure coil causes error. So there is a one error may be occurred due to the inductance, the pressure coil. And torque is very less. Torque produces a very small, and low sensitivity. Sensitivity is a very less. And screening is needed to avoid the stray fails. So that is we require the steel coated is required to avoid the entering of the stray magnetic field to avoid the errors. These are the some disadvantages. Okay. So, what we have covered in this class? We covered the construction of dynamometer type instrument and working principle of dynamometer type instrument and a dynamometer type instrument as a voltmeter and ammeter, and what are the its few merits and demerits we have covered. Okay. So, thank you for listening my class.